So as we promised in the last class, here we will be discussing a very simple numerical on the Coulombs force. This is just to illustrate. Okay, this might be sufficient for the board exam. For competitive exams, you'll have to do more practice than just this, but this just illustrates how to solve numericals based on the Coulombs force. So here, this is the formula for the Coulombs force, and again R21 is a unit vector. This is the destination, okay, and this is the source. It is from 1 to 2, that is the unit vector from 1 to 2, and this is the force on the charge number 2. So this is what the Coulombs force takes on. Now if I have two charges of 5 Coulomb and 2 Coulomb which are separated by 10 meters, I need to find out what would be the force in Newton. So I would simply apply this formula. The value of K I know, so let us just try to find out the force, the magnitude of the force, what that would be. So value of K I already know, it is 9 into 10 raised to power 9. Then I know the value of these two charges, these are 5 and 10, and then I also know the R, which is 10 meters. So everything is in SI units, so my job is become very simple. So this is 5 and 2, sorry, and then this is just 10 into 10. So 5 into 2 is 10, this 10 cancels, and therefore my force would come out to be 9 into 10 raised to power 9. This is divided by 10, so I reduce the power, 9 into 10 raised to power 8 newtons. Okay, the same thing I could have obtained if instead of using directly the value of K, if I had used 1 by 4 pi epsilon naught. But for purposes of solving the numericals, we have to remember the value of K as well as we also have to remember the value of epsilon naught. Both of these are important. So value of K is given here. This is our value of K. Okay, and this is the value of epsilon naught. You have to remember both of these values, and one is only the power is different. Okay, this epsilon naught also you can approximate by 9, and the value of K also you can approximate by 9. So one is epsilon naught at 10 raised to a minus 12 and K is 10 raised to power 9. Okay, so hopefully things are become very clear with this numerical, how to go about solving. So practice many such problems, and based on various charges, various charge configurations, 2 or 3 charges when they are placed in different locations. So practice all of those problems, and you will definitely be able to solve such numericals in exam because they will be asked.